So we're going to start with the reciprocal identities, and I have these written in a very specific manner. So write them in the exact same place as me. Don't like mix and match, and I'm going to explain why. So the first one, reciprocal means you've flipped something. So you're going to have fractions here. So the first one is 1 over sine of theta. You do have to put the theta. You could also call it x if you want. Typically, theta is the angle, but you can't have an empty sign. It can't be sine of nothing. So you have to put something there. What do you think that equals? Because you do actually know what the reciprocal of sine is. Which trig function is the reciprocal? Cosecant. And so next to that, if you do the reciprocal of cosecant, 1 over cosecant theta, that is going to give you sine. Remember, those are the two that go together if you just flip them over. So you already know it. We're just writing it out in sort of a more formal way. So next line down, if you do 1 over cosine, which function is the reciprocal for cosine? Secant, good. Do you remember those are the even ones? Because look down the paper. Do you see the ones called even and odd? Like you still have to know which ones are which, okay? So over here, if you do 1 over secant, that's going to equal cosine. Again, don't view this as new information. You already know this. We're just writing it out officially. All right, and then the third one here, if you do 1 over tangent, you reciprocate tangent, what do you think you're going to get? Cotangent? And if you do 1 over cotangent, you're going to get tangent. So those are called reciprocal identities. You are just flipping it. You already know which ones go together. Quotient identities. A quotient is a fraction. I'm actually going to start with this one. And again, I'm writing them in a specific order for a reason. I'll explain why. If you have sine over cosine, I don't always say the theta, but it needs to be there. You can't have an empty trig function. It has to be sine of something. So sine over cosine. Now that would be y over x. What do you think that is? Which trig function was y over x? Tangent. Or opposite over adjacent. You can think of it that way too, that like it's all connected. Like you do know this, I promise, right? Now, if you flip that over, instead of sine over cosine, if you have cosine over sine, use your instincts. What do you think? If this one's tangent and you flip it over, this one's going to be cotangent. Here's how I kind of remember that one. Do you see how the cosine is on the top and it equals cotangent? That's kind of how I match that up in my mind. I mean, it's memorization. You're going to have to remember it somehow, right? Those are called quotient identities. Quotient means fraction. You've got a fraction. These next three are Pythagorean identities, and they come from the Pythagorean theorem. So I'm going to explain it with a triangle. So go ahead and draw a triangle in quadrant 1. The y value is sine. The x value is cosine. If you're on the unit circle, what is the hypotenuse or the radius of the circle? What heard somebody say it back then? 1. It's going to be 1. So if you do Pythagorean theorem, it's going to be, you remember a squared plus b squared equals c squared? So you're going to have sine squared plus cosine squared equals 1 squared, which just is 1. So it's sine squared plus cosine squared equals 1. And we're going to put the brakes on there and have a brief conversation about how you square trig functions, because it does matter. I know, just don't go to sleep on me. Do you see how I put the squared kind of in the middle? That means you're doing sine times itself. Do you see how we squared the sine function? If you were to write this instead, what did you actually square? Because it's not sine. The angle, right? The theta. What that means is this. You just multiplied theta times itself. Do you see the difference? And it does make a difference. So that's why you have to put the squared like after the trig function, after the sine part. All right, now there's 2 others of these. I don't necessarily memorize them as they are. I just memorize this first one, and then I use it to get the other ones. So the first thing that I would do is go through and divide all three of these by cosine squared. I'm going to divide all three of them by cosine squared. If you take sine squared and divide it by cosine squared, what did we just say sine over cosine is? Tangent. So if you have sine squared over cosine squared, you get tangent squared. Plus, now if you take cosine squared and divide it by cosine squared, anything divided by itself is going to be 1 equals. And then if you take 1 and divide it by cosine squared, well, what did we say 1 over cosine is? What's your reciprocal of cosine? Secant. So it's going to end up being secant squared. Now I'm going to do the exact same thing, but I'm going to take all three of these and divide them by sine squared. It won't show up on the video, but let me show you what I mean. If I take this and divide it by sine squared, and take this and divide it by sine squared, are you coming with me? Sine squared. Okay. What do you get for the first part? Anything divided by itself is going to be 1 plus, what do you guys think for this part? Cosine squared over sine squared. Cotangent, just with a squared in there. Because cosine over sine is cotangent, it's just squared. And then 1 over sine squared. Well, what's your reciprocal of sine? You're just flipping it. It's cosecant squared. I hope you didn't write outside of the box like I did. I wish I hadn't done that. Now you can't just flat out memorize them. That's how I explain it. I only memorize the first one and then I just use it to get the other ones. But a lot of people don't like that and they'll just flat out memorize those too. And that's fine. You know, how I'm presenting it. As a teacher, teaching memorization is very difficult because I actually can't teach you to memorize. All I can do is present this and then you have to do what you will with it. You know, it's a very difficult thing to teach because it's not really teaching, it's presenting. It's here it is. Enjoy. All right, so the even and odd identities, and again, I have these in a specific order. This is where you have a negative angle in there. So I'm going to list out these first three. And so I just put the negative angle in there. It's negative theta. So here's the rule. The even ones turn positive. Even ones turn positive. The odd ones turn negative. So out of these three, which one is the even one? Cosine. So that's just going to be cosine theta, positive cosine theta. It will just turn positive. Basically, just get rid of the negative. The odd ones, which are these two, turn negative. So it's going to look like that. So the even ones turn positive, the odd ones turn negative. And so I'm going to put the reciprocal ones next to them. So this one will be cosecant of negative theta. And so again, the even ones turn positive, the odd ones turn negative. So out of those three, which one is the even one? Secant. Good. So that is just going to turn positive. It'll just be secant of theta. The other ones are going to be negative. Even, positive, odd, negative. That's really all you need to remember for those ones. And you're like, how much more? There's one more set of identities. Here's one more. All right. Co-function identities. You know how sine and cosine, they both say sine except with a co, and secant and cosecant, and tangent and cotangent. You just add or remove a co. These are the ones that go together. And again, I have them written a certain way. So if you have sine of 90 minus theta, or if you see it in radians, what is 90 degrees in radians? Pi over 2. So if you see a pi over 2 there instead, it means the same thing. You just add or remove a co. So for sine, that would be cosine. You just add or remove the co. So right below there, if you do cosine 90 minus theta, what is that going to give you? sine. This is actually another reason why I don't let you abbreviate them and say cot and stuff like that, because if you say them correctly, then it'll make sense with adding and removing the co. All right, so for this one, if you do cosecant 90 minus theta, just remove the co, what do you get? Secant, good. And then if you do secant 90 minus theta, you're going to get cosecant, secant and cosecant. You just add or remove the co. And so if you have cotangent 90 minus theta, that's going to give you tangent. And if you have tangent 90 minus theta, that's going to give you cotangent. Tangent and cotangent are both co-functions and reciprocals, which is nice. The other ones get a little bit jumbled up. Let me recap, and then we'll do our break. All right, listen to me. Let me recap the whole thing. These ones you already know. You're just flipping it. And don't stop listening to me. Don't turn me out. You're just flipping it. These ones, if you remember, sine over cosine is tangent. This one's just the reciprocal. These ones are tough. You're going to need to spend some time memorizing it. I only memorized the first one. Sine squared plus cosine squared equals 1. That's the most common one to come up. If you see negatives, how do you know which ones turn positive? The even ones turn positive, the odd ones negative. And then if you see a 90 minus theta, you just add or remove a co. All right. The reason I was real picky about where I wrote them is, this is what I did for you. If you want to cut these out, they have become flashcards. You just made yourself a set of flashcards. Do you see what I'm saying? If you were going to go make flashcards to practice them, if you cut these out, I made them match up with what's on the other side, if you would like to. But if you were going to make flashcards, you just did. Okay. So we'll do our halfway through break. All right, so doing these is like doing little puzzles. Again, some people end up really liking this, some people really don't. You're gonna have to decide, how you feel. But you're looking for things that cancel. And so what you want to do, if possible, is turn everything into sines and cosines. So you want to look at it and go, what can I replace? It's a series of replacements. You're replacing things. So look at the first one. What could you replace tangent with? And the going is going to be slow at the beginning until you start to get the hang of this. Maybe you could pull your papers apart, unstaple it so you can look back. I want you guys to find what you could replace tangent with that has sines and cosines. What does tangent equal? Good, perfect. So we are going to replace tangent with sine over cosine. So I removed tangent and I replaced it with sine over cosine. Do you see how I did that? Times, so I'm going to put a little dot. Do you see how that just says cosine? It's already cosine, but I would write it as cosine over 1. Anything is itself over 1. And then you want to stop and be like, oh, I did a replacement. Now what can I cancel out? Or where does that take you? What could you do next? Yeah, cancel out the cosines. And so the answer is sine. Now, what I always get asked is, how do I know when I'm done? When you get it as simple as you can get it, on the test, I have it as matching. If you're ever not sure, just ask me and I'll tell you if you're done. Okay, so don't stress about that. Just keep going until it's as simple as you can get it. So let's look at this one. Let's try it again. What can we replace tangent with? Hint, you just did it. It's perfect. You're going to replace tangent with sine over cosine. And again, these are like little puzzles. Try not to resist it. If you're like, oh, I hate this, in your corner, try to just get on board though, all right? Fraction bar, so draw a gigantic fraction bar, and then that already is sine. You want to try to turn it all into sines and cosines. That already is sine, but I would write it as sine over 1. Because again, having it as a fraction helps. All right, then we're going to stop and take a look at what we've got. When you divide by a fraction, that is multiplying by, good, perfect. So this is going to be sine over cosine, that first part, times, so put a little dot, and you're going to flip this over. You're going to reciprocate it. Then what? Sines cancel, so you get 1 over cosine. And then there is one more step. That's a reciprocal identity because it's the 1 over something. What's your reciprocal of cosine? Secant. And again, you already know it. Don't view it as new information. You already know it. Excuse me? It is. I'm on your side, 100%. On the test, I have it as matching. Okay, if that calms you down. But you're having a good attitude about it, so that doesn't bother me. All right, do you see the 90 minus? That's co-function. You're either going to add or remove a co. So how do you say this one? Secant. So add a co and it becomes cosecant. All right, so that's going to be cosecant theta minus. Now, do you see how do you say this one? Cosine. So remove a co and it's sine. You might be like, how did that make it better? Well, we got rid of the 90 minus stuff. That's good. Now you want to turn it all into sines and cosines. If possible, you want to make it all sines and cosines. So what's your next replacement? What can you replace cosecant with? One, good, it's reciprocal. 1 over sine. My handwriting's getting messy. Let me fix that. 1 over sine minus, and then how have I been telling you to write this? If you're not going to change it, yeah, put it over 1. Now those signs don't cancel. Why not? Why can't we cancel them? You're subtracting, right? Not multiplying. When you add or subtract, you need a common denominator. So what is your common denominator? Look just at the denominators. It would be sine of theta. So this one's good. We're going to multiply this one by sine theta. And then what I usually do at that point is circle the numerator. The whole point is that you're trying to put all this together. That's a personal preference. If you don't want to circle that, you don't have to, but that's everything we're putting together. So it's going to become 1 minus, and how do you think you would write sine times sine? Good, and the squared goes like in between there. So we put all that together over our common denominator, which was sine. Now, where do we go from there? Do you see the numerator is 1 minus sine squared? When you see a squared, you want to think of these Pythagorean identities. And I wrote them up here on the board so that we'd have them. Now, what's on there is 1 minus sine squared. So what can I replace 1 minus sine squared with? Cosine squared. I would write, instead of cosine squared, I would write cosine times cosine, and you'll see why in a second. Do you get that that means cosine squared? Got it twice. And the reason I would do that is your last step is you can do one more replacement. What can you replace cosine over sine with? I don't expect you've memorized it yet. Just flip back. That's cotangent. So you end up with cotangent times cosine. So you got rid of all the fractions, you got rid of all the squareds. It's as simple as it's going to get. There's no other replacement you can do that will make it look any better. And again, if you aren't sure if you're finished, just ask me and I'll be like, you're done, or you have more steps. Okay? If you're like, this is hard, you're correct. It is. We're going to get the hang of it though. Do you see how those have negatives? That means even or odd. The even ones turn positive, the odd ones turn negative. So is secant even or odd? Secant is even, so that one's going to turn positive. It's going to just be secant of theta. Times, so put a little dot. Cotangent is negative. Negative cotangent of theta, because it's odd. That one's going to stay negative. Then you're going to replace them all so that they are sines and cosines. It's a series of replacements. What can you replace secant with? It'd be 1 over cosine. Good. Times, and then negative. What can you replace cotangent with? Again, I don't expect you've memorized it yet. I just showed it to you, but look back. Good. Cosine over sine. Good. You guys are getting on board. I get some people that just resist this so hard and I can't do it for you. All right, and then what? What's going to happen there? Cosines cancel, you get -1 over sine. And then you've got one more step. What's your reciprocal of sine? Cosecant. So it's negative cosecant. Cool. Do you see these squareds in here? When you see the squareds, you want to think Pythagorean theorems. And I wrote them up here. What does that one say? Secant squared minus tangent squared. So if you have secant squared minus tangent squared, what can you replace that with? What? So this entire thing, secant squared minus tangent squared, is 1. Isn't that cool? Plus 1. And so weirdly, what's the answer to the whole thing? 2. They're not all going to be really hard. That one was easier. Do you see all these squareds? You want to think Pythagorean. Now, they're not right next to each other, but do you see how we have a sine squared plus cosine squared? What does that get replaced with? Sine squared plus cosine squared, 1 plus tangent squared. And then look up there again. What can you replace 1 plus tangent squared with? Secant squared. Good. Again, it's a series of replacements. It's what can I replace it with? All right, this last one here. Do you see how it's this whole thing squared? That means you need to write it twice. You've done this before and very successfully, just not with sines and cosines in it. You've done it with just x's and y's. Do you know what I'm saying? But it's the exact same concept. You've done this and very well. All right, we're going to distribute everything together. 1 times 1. 1. The outsides are going to give you 1 sine of theta. The insides are going to give you 1 sine of theta. So together, that will be 2 sine of theta. 1 plus 1 is 2. That's all that is. And then the last, sine times sine, is sine squared. Good. And then you've got that plus cosine squared at the end there. So look through that. Do you see something we could replace? Hint, it's on the board behind. Yeah, sine squared plus cosine squared. What can you replace that with? 1. Good. And then the last thing you can do is combine like terms. So what will this come out to be? Good. Good, you guys are getting there. It takes practice. Not easy by any stretch of the imagination. All right, these ones are a little nicer in a way when it says verify, because you actually have the answer on the paper. Do you see how you have this equals this? You pick one side of the equal sign and you mess with it until it equals the other. So you actually know what the answer is going to be. Now you should start with the more complicated side and try to reduce it down to the less complicated side. Which side here is more complicated? Well, it's going to be the one that has the plus sign in it. So we're going to start with the left side. Pretend this isn't here. What could you replace cotangent with? Perfect. Cosine over sine. Plus, what could you replace tangent with? Sine over cosine. Don't even write the rest of it. We're going to just eventually make it equal that. Now, when you add fractions, you need a common denominator. So your common denominator is going to be sine times cosine, like you just need both of them. So you're basically giving them what they're missing. This one is missing a cosine, and this one is missing a sine. So you're multiplying them by each other. It's like this. What's the common denominator between 2 and 5? 10. Like you would just multiply them together. It's like that, but instead of numbers, you have all this. So again, this is personal preference. What I usually do is circle the numerator because you're trying to put all that together. What is this first part going to be? Cosine squared, good. Plus, and then what's this part gonna be? Sine squared, good. Over the common denominator, which we said was cosine times sine, or sine times, it doesn't matter what order you write those in, but both of them. We're nearly there. What's your next replacement? What is the numerator going to equal? 1, good. And then your last step, because it's 1 over, it's reciprocal. So what's your reciprocal of cosine? 1 over cosine. Secant. Again, you already know that. Don't treat it like it's new information. You've been doing that a long time. And then 1 over sine. What's your reciprocal of sine? It's cosecant. Oh my gosh, do you guys see how that is what's on the other side of the equal sign? Like the answer's there. You just have to get it. All right, which side of this one do you view as the more complicated side, the left or the right? Definitely the right is more complicated, so we're going to start with that one. There's kind of a trick to this one. Do you see how this is 1 minus sine? We're going to multiply the top and the bottom by 1 plus sine. It's called a conjugate. We've done that before. Do you remember that, sort of? Conjugates, like the opposite operation? We did do that earlier this week. If you don't remember, that's... it was back in the quadratic. Anyway, numerator. I don't think I really want to distribute that through there. Let's just leave that alone. If you distribute that cosine squared, that's going to turn really awful. So I think I'm going to just leave it alone. Like, hey, Miss Cole, looks like you just recopied it. Sure did. All right, down here, we're going to multiply them all together. 1 times 1 is 1. Now look, and this was the whole point of doing this. Do you see how the outsides will give you 1 sine of theta plus 1 sine of theta, and then the insides give you minus 1? So if you have a plus 1, minus 1, they cancel out. So those are gone. That was the whole point. And then you're going to have minus sine times sine is sine squared. That's what a conjugate does. It cancels out the middle part. All right, now next replacement. 1 minus sine squared. If you have 1 and you minus the sine squared over, what can you replace it with? Good. So this is going to get replaced with cosine squared. So that denominator got replaced with cosine squared. It's that identity right there. And then you're nearly done. What's your last step? Yeah, cancel those out. And is 1 plus sine of theta what's on the other side of the equal sign? Yes, so that's the way you can check. All right, which side is more complicated for this one? Definitely the left. I would start with this denominator. 1 minus secant squared. I'm going to stand for this one. Ooh, that's going to be a little tricky. Can you guys watch me point to this? I know this last one and you're tired, but can you follow me? If you do 1 minus secant squared, there'd be nothing left over here. Do you see what I'm saying? So you would have to subtract over tangent squared. Do you see? Are you following me there? So if you do 1 minus secant squared, it's going to equal not tangent squared, but oh, good. You came with me on that. Negative tangent squared. So we're going to replace that denominator with negative tangent squared. We just had to do a little bit of maneuvering. So now I'm going to separate this into 2 separate parts. We're going to have sine squared over negative tangent squared minus tangent squared over negative tangent squared. I just wrote it as 2 separate fractions. I took, this part, and then I did this part. And honestly, I think it's going to kind of fall into place after that. What can you replace tangent with? And you haven't memorized it yet. Look back. What can you replace tangent with? So that's right, but I want sines and cosines. Sine over cosine. It'll be squared. Good. All right. So we're going to have sine squared. I'm just going to stick that negative out front over Sine squared over cosine squared. When you have tangent equals sine over cosine, just throw the squared in there. It's the same thing except squared. And then what's going to happen with this? Conveniently, cancels, and the negatives cancel, so you get +1. It's like that whole mess of a fraction, +1. All right, when you divide by a fraction, that is the same thing as multiplying by the reciprocal. So I put this over 1, and I'm going to flip this over. So this whole mess, I took the sine squared and put it over 1. You can always put those 1s in there. You're going to reciprocate it, and then we got that +1 at the end, which is sort of weird. But nearly there, what's going to cancel now? All right, the sine squareds cancel. That leaves you with negative cosine squared +1. So what can you replace negative cosine squared +1, or 1 minus cosine squared, so to speak? What can you replace that with? Sine squared. And is that what was on the other side of the equal sign?